Hello everybody, my name is Elliot Kimmel and this is a science tutorial for grade 10 students. For this video tutorial you're going to need a couple of things. First of all, you're going to need your textbook open to the periodic table at the back, and you'll also need the handout or printout, electron arrangements, and the Bohr-Rutherford diagram. So we are going to have a look at that handout, and as I reveal the parts of that handout, you can see I've got the handout right here. You guys are going to be copying in the information that's going to be revealed below here. All right, so go ahead, get out your textbook to the periodic table and get the handout, something to write with, and let's get started. All right, electron arrangements and the Bohr-Rutherford diagram. So go ahead and fill in the blanks as I read through this. The Bohr-Rutherford diagram of the atom is a useful way of representing the arrangement of electrons around the nucleus for the first 20 elements. Each electron, orbit, or shell is shown as a ring around the nucleus. Evidence indicates that only a maximum number of electrons can occupy each orbit. The first orbit can hold a maximum of 2 electrons. Electrons with atomic numbers above 18 must have some electrons in the fourth orbit. Because all atoms are electrically neutral, the total number of electrons in these orbits must match the number of protons in the nucleus. All right, so let's discuss this. Over here on the right side of your screen, I've got a representation of an atom. And I have drawn here the electron shells or orbits. You can see them moving around there. This yellow one here would represent the first energy level or the first orbit or shell. And this green one here represents the second level. Now I could have drawn extra orbits or shells as well outside of this, and we will be doing some of that. This region here represents the nucleus. Now, unlike the nucleus of a cell, there's no nuclear membrane, right? The protons and neutrons, which are subatomic particles, just reside in the central region, and that's called the nucleus. The cyan particles here represent the neutrons, and neutrons have a neutral charge. So I've given the symbol down here, N with a superscript 0. And the protons, these guys, have a positive charge, and so I've illustrated that as P+. That's the symbol or the short form or abbreviation that you can use. Electrons are in orbits or shells. And like I said, this one here is the first shell or first energy level. So this is an electron. This green thing here, that's an electron. This electron is in the second shell or the second orbit. And electrons have the symbol E with a negative sign because they're negatively charged. So neutral neutrons, positive protons, and negative electrons. Now, each shell can hold a maximum of electrons. So this first shell here, you can see I've actually drawn in 1, 2 electrons, and I've put them in a particular position. I like to put electrons going around the side, sort of like the compass points. So the first electron's there, the second electron is there, and that is all that the first energy level can hold. When you jump up to the second energy level, I'm going to put an electron here, and then here, and then here, and then over on the side there, and then I would start pairing them up. But I'll show you how I'll do that. All right, so that pretty much describes the information in the first section there. So let's go on to the next paragraph. An atom of lithium, and I've got the symbol down here for lithium. There's the chemical symbol, and I've got the atomic number and the mass number. We'll talk about that in a moment. An atom of lithium is sometimes represented as Li7. This means that this particular atom has a mass of 7, so that's the mass number down there. The mass number is the total number of protons and neutrons. So the mass number describes the protons and the neutrons that are in the nucleus. Lithium atoms always have 3 protons, so this atom must also have 4 neutrons in the nucleus. To balance the charge of the 3 protons, 3 electrons must be orbiting the nucleus. The first orbit can hold up to 2 electrons. Since the third electron cannot fit in the first orbit, it has to go in a second orbit. So let's talk a little bit about that. Okay, so like I said here, we've got the symbol for the lithium atom here. And then above that, to the left, we've got this thing here, and that represents the atomic number. Now, the atomic number tells you the number of protons, positively charged particles, in the nucleus. And if this is a neutral atom, and for this worksheet, these are all neutral, it also tells you the number of electrons, because the protons and electrons must be equal so that they sum to 0. So if there are 3 protons, there are going to be 3 electrons, and that's what it talks about here. 3 protons and 3 electrons as well. No, you can't really see that. All right. Now, the mass number is given down here, and the mass number is the number of protons and the number of neutrons. So if the mass number is 7 and the atomic number is 3, that means 7 minus 3, that equals 4, and that actually tells you how many neutrons there are. All right, well, we'll get into that in a bit. So 3 protons, 4 neutrons, 3 electrons. This atom up here actually represents what we would have for a lithium atom. We've got these red things. These are the protons. So there are 3 protons in the nucleus, and there are 1, 2, 3, 4 neutrons in the nucleus, and that's the mass number. And the reason that the mass is comprised of the protons and the neutrons is because electrons are so small that they don't actually contribute to the mass. So the mass number down here only reflects the number of protons and neutrons. Now, there are 3 electrons to balance the charge of the positive protons, because the neutrons are uncharged. So there's nothing electrically that they contribute. The only charge contributed by the nucleus is the 3 positive protons here in the nucleus. So each electron is negative to balance that charge. So this becomes a neutral lithium atom. Because there are 3 electrons, 2 of those electrons go in the first shell, and then that shell, or energy level, or orbit, all sort of means the same thing. That shell is now full, and that 3rd electron has to go into the 2nd orbit or shell. And then we start filling this one up. 3rd paragraph. The 2nd orbit can accommodate up to 8 electrons. So as you proceed from element to element, the number of electrons in the 2nd orbit increases by 1 until there are 8, the maximum number. So the 2nd shell here can hold 8. Fluorine has 7 electrons in its 2nd orbit, and neon has 8 in its 2nd orbit. The outermost electron of sodium is in the 3rd orbit. Notice that the period or row number of an element tells you how many electron orbits or shells the atoms have. All right, so let's talk about that. So as we said, the first orbit here can hold 2 electrons, and we can see that here with the lithium atom. That shell or orbit is now full. When we go to the 2nd shell here, it can hold a maximum of 8 electrons, and I'll show you how we draw those in a moment. Once this shell has 8 electrons, it's now full, and then we would have to go to a 3rd shell. And once that's full, we'd go to a 4th and to a 5th, etc. Now, to figure out how many electrons there are, as we said, we're going to look at the atomic number. So down here we refer to fluorine having 7 electrons. Well, let's go to the periodic table now. Look in the halogens, which is group number 17 on the far right, and find fluorine. Notice the atomic number for fluorine is 9. This means it has 9 protons. By definition, that's what the atomic number means. And it also means that it has 9 electrons, as long as it's neutral. So those electrons will go 2 in the first shell. That leaves us 7 more electrons. So we're going to have 1, 2, 3, 4, and then I'm going to pair them up, 5, 6, 7 electrons. That leaves 1 unpaired electron. There's no electron there, and that's our 7 electrons. If we had another electron here, this second shell or orbit would be full, and we would now go to the third orbit or shell. The paragraph here mentions that the period or row number can tell you how many electron orbits or shells there are. So again, if you look at fluorine, the halogen there, go back to the left-hand side of the periodic table and you will see a number 2 beside the period. And that tells you that there are 2 electron shells or orbits. 1, 2 for fluorine. Okay, so that basically covers the information on the printout, and now it's going to be time for us to draw some Bohr diagrams. So you can see in the bottom of your worksheet there, you have a space to draw some diagrams. So let's go ahead and do that. So we are going to draw the Bohr diagrams for a number of these. So we're going to draw hydrogen. Now hydrogen, I'll draw the symbol up here. You don't have to draw this. There's the symbol for hydrogen, and hydrogen has a mass number of 1. Now it's really 1.01, but we round them to the nearest whole number, and it has an atomic number of 1. This one here, the mass number, tells you how many protons and how many neutrons. Well, it's only number 1, so is it a proton or is it a neutron? Well, the atomic number of 1 tells you by definition the number of protons. So this must be just 1 proton. If it's 1 proton, there's also 1 electron to keep it neutral. So the way that we draw this is like this. So you're going to do this in the space now. We're going to draw a circle, and that represents the nucleus. And in the nucleus, I'm going to draw the number of protons and neutrons. There's only 1 proton in hydrogen, so I'm going to draw 1 p+. There are 0 neutrons, so we don't do anything. Now, we have only 1 electron to deal with, so I'm going to draw the first energy level or shell or orbit, like that. And I'm going to draw 1 electron up here, and that is it for the Bohr diagram for hydrogen. There's only 1 electron, nothing else. Now, if you go to the right-hand side of your periodic table, you will see helium. So here's the symbol for helium, right? It's got a mass number of 4, and it's got an atomic number of 2. This means there are 2 electrons, and hence 2 protons as well. And there's a number of 4 here. That means 4 protons plus neutrons together. Now, to figure out the number of neutrons, you take the mass number, which is 4, minus the atomic number, which is 2, and that gives you 2. That means there are 2 neutrons. There are 2 protons and 2 neutrons equaling 4. So let's draw the Bohr diagram for helium. Draw a circle, and in the circle, which represents the nucleus, you're going to draw 2 protons and 2 neutrons. So there's the nucleus, and now we draw the first orbit or shell. Boy, that's messy. And there are 2 electrons in this energy shell. Now, I like to put the first one here and the second one off to the side. Now, there are people that put the second electron right there paired up, and it makes sense. But I promise you that this is a better way to do it for reasons that will become clear very soon. All right, let me clear that mess up and go on. Now, lithium is drawn for you on your printout, and you're going to notice that when I drew lithium, I've got the nucleus there, I've got the first shell there, and I did pair them up because that is similar to how the book does it. And then lithium has 3 electrons, so they put the third one, or I put the third one up there. That's not really how I like to do it. So we're going to go on and we'll do beryllium. And beryllium, symbol Be, has a mass number of 9.01. We round it to 9, and an atomic number of 4. So let's go ahead and draw the Bohr diagram. Draw your nucleus. 4 protons because of the atomic number. To get the number of neutrons, 9 minus 4 is 5, so 5 neutrons. And then we're going to start adding our electrons. So our first shell, okay, 4 protons means 4 electrons. So first one goes up at the top, second one on the right. Now we have 2 more electrons to go, but this first energy shell is full. So we draw a second energy level, or orbit, or shell, like that, but hopefully yours is a little bit more circular. And we're going to put our other 2 electrons. So I start at the top again, and I go to the side again. So there are our 4 electrons, 4 protons. So this is a neutral atom. Boron, capital B, mass number of 10, atomic number of 5. So here we go. 5 protons. 10 minus 5 is 5 neutrons. Put that in. Draw your first shell. Okay, we got to go for 5 electrons. So first electron there, second electron there. Shell is full. Go to our second shell. We've got 3 more electrons. 1 at the top, 1 on the side, 1 on the bottom. And perhaps you can guess the next one's going to go there. 5 electrons, 5 protons, neutral atom. Let's go on and do carbon. Carbon has a mass number of 12 and an atomic number of 6. So we'll go ahead and draw the nucleus for carbon. 6 protons, 6 neutrons, right? 12 minus 6. And now it's time to start doing the electrons. First orbit, 1, 2 electrons. The shell is full. On to the second shell. Okay, 4 electrons. 1, 2, 3, 4. Just like that, going around the compass points. Now, this is the best way to do this because in the future, you're going to see that carbon atoms bind with other atoms. For example, hydrogen. If we wanted to create the molecule of methane, CH4, the hydrogens are going to be placed around the edges. And the electron here, in addition to hydrogen's electron, which we'll see later, is going to be involved with a bond. So we're going to have bonds right here. And so this method of drawing the Bohr diagram is better than if we had paired up the electrons. This illustrates the real structure a little bit better. But you'll see what I mean as we go on. Okay, nitrogen. Capital N, atomic number 7, mass number 14. So here we go. 7 protons, 14 minus 7, 7 neutrons. First shell, 1, 2 electrons. Looks like a pumpkin to me. Second shell. Now watch what we're going to do here in our second shell. We have 5 more electrons. 1, 2, 3, 4. We've got 1 more electron. Now we pair it up. So you can see that there's a pair of electrons and there are 3 unpaired electrons in the second shell. Well, this is going to help us because later in the course, we'll be doing the structure for ammonia, which is NH3. And you can see that hydrogen would fit nicely there and here and here. So we are going to get a really nice ammonia molecule by spreading out the electrons in this way. Okay, now your job is going to be to complete the rest of the Bohr diagrams on the front side of your worksheet, working through that second period. And then I want you to go on the back of your sheet doing the Bohr diagrams from sodium all the way to calcium, which is going to have an atomic number of 20. That's a 20 right there. And that's all we're going to be doing is up to calcium. We're not going to go beyond that. All right. So what I'd like you to do is to pause the video at this point. You guys go ahead, draw the rest of those up to calcium, and then start the video again, and I'll draw a few of those harder ones and show you how that's done. Okay, so go ahead and pause the video now. Okay, welcome back. Let's continue here. Hopefully you've got all of them drawn up to calcium. I want to show you a couple of these. Let's do aluminum. So here is the symbol for aluminum, Al. It's got a mass number of 27, rounded up, and it's got an atomic number of 13. So I'm going to come over here, and I'm going to draw my nucleus. I need 13 protons. I need 14 neutrons. So that's a lot of electrons I have to deal with. 13 protons means 13 electrons. So let's go ahead and do it. 1, 2 electrons. Second shell. 1, 2, 3, 4 electrons. Now it's time to pair them up. 5, 6, 7, 8. Now that's a total of 10 electrons. The first energy level or shell is full with 2. The second energy level or shell is filled with 8. That makes a total of 10. Both of these shells are full. Means we have to go to a third shell. And there are 3 more electrons. So I'm going to put 1 there, and 1 there, and 1 there. And that makes our aluminum atom, a neutral aluminum atom. Let's go on and do the hardest one, the biggest one, as they're not hard, are they? Let's do calcium. Calcium has a mass number of 40 and an atomic number of 20. So we got to deal with 20 electrons. So I'm going to draw my nucleus here with 20 protons and 20 neutrons. All right, first energy level or shell, 2 electrons, and it's full. Second energy level, 1, 2, 3, 4, 5, 6, 7, you guessed it, 8. That's 10 electrons there, but we've got 10 more to go. So I'm going to the third energy level. And I'm going to go 1, 2, 3, 4. Now I'm going to pair them up. 5, 6, 7, 8. All right, how many electrons have we got? 8 and 8 and 2. We still have 2 more electrons to go. Now, here's the thing to realize, all right? Despite what you may have learned in the past, you may have seen something called the 2n squared rule, which tells you how many electrons an energy level or shell can hold. However, we're not going to deal with that this year. We are going to look at the fact that the third energy level can hold 8 electrons, and then it's full, and then we move on to the fourth energy level. You'll see as you go on more in chemistry that that's not exactly true, but it works fine for us. So once there are 8 electrons in the third shell, we have 2 more electrons to go. I'm going to go way out here to a big fourth shell, and I'm going to draw 1 electron there, 2 electrons there. Okay, in total. So that's our 20 electrons, and you can see that the outermost electrons here, these 2, 1, 2, they are in the fourth energy shell. And if you look back at the family or group that calcium is in, right, there is beryllium, there is magnesium, there's calcium and strontium. All of these are the alkaline earth metals, and all of them have 2 outer electrons. If you were to draw the Bohr diagram, well, have a look at the beryllium you've done, and have a look at the magnesium you've done, and then compare it to calcium, and you'll notice they all have 2 outermost electrons. And this is part of why they are in the same family, and they are going to react in a similar way because it's the outermost electrons which are called the valence electrons, because this is called the valence shell. The outermost electrons or valence electrons are the ones involved with chemical bonding. All of these other electrons in here are somewhat shielded. Think of the outer part here as the outer skin of the atom, and everything else is interior to that and sort of hidden like the bones and the guts of the atom. And it's the skin of the atom that is going to react with other atoms. So as you draw Bohr diagrams, for example, the halogens, fluorine, chlorine, bromine, iodine, you are going to notice that there are 7 electrons in the outer shell or the valence shell for all of these, and this will determine the reactivity. And likewise, the alkali metals, lithium, sodium, potassium, even hydrogen has 1 outer electron, 1 valence electron, and that determines its chemical reactivity, and that's why this is the periodic table. All right, so hope that helped. See you soon.